Okay, hopefully you now have a much better idea of how ginormous or gargantuan a mole really is. But your next question should be, okay, that's great, Norton. How are we going to actually use this? This is how we use the mole. The first thing we use the mole for, well, the eventual end game for using the mole is to be able to find out how much product we make in a chemical reaction. A mole is your connector in a balanced chemical equation. And since this is Chem A and we're still using the basics, building to the point where we can do some cool chemistry, our using the mole in this chapter is very similar to what we did in chapter 5 in that we are just using it as a conversion. Well, on the periodic table before we used molar mass. And what are the units of molar mass? Well, they are grams per mole. And what that is a conversion between grams and moles. And where do we find the molar mass? We find it on the periodic table. That is correct. Okay, well, we're trying to convert this many moles of aluminum to grams of aluminum. So the conversion we would find on the periodic table. So take a minute, pause it, and see if you can find the molar mass of aluminum. If you came up with 26.98 grams of aluminum per mole, you are correct. To start, we start with what's given, which is 18.54 moles of aluminum, and do not get lazy and drop the units, especially not this one. It will make a difference as these problems become more complex that you actually keep track of whose moles they are. In these first couple of problems, it'll seem like a waste of time. I get that, but please get in the habit of doing it. Okay, if moles is here, we have to chase this unit down. Our conversion says 1 mole of who? Yeah, aluminum. For every 26.98 grams of aluminum. Now, if you notice, fortunately for us, our moles of aluminum just canceled out. They have to be moles of aluminum. You can't cross moles of one thing out with moles of another thing. They have to be the same. Moving on. Multiply, you'll get the right answer. Okay, when I multiplied these two numbers, I ended up with 500.2092. That's a 0. So now we just need to look at significant figures. This problem has 4 sig figs, so I only care about those 4. My final answer, and the unit, grams of aluminum. That's it. There's another way we can use the idea of a mole, and that is to convert between moles to atoms. And from the video, you should have learned that for every 1 mole, that's going to equal 6.022 times 10 to the 23rd. And that's a number you have to know. Right?
No.
Is that a number you have to know?
What?
6.022 times 10 to the 23rd?
Yeah.
Oh, yeah. So that's, in this case, atoms. We could use it for molecules, but I don't have molecules. I have atoms. So we're going to start with what's been given, which in this case is 45 moles of calcium. And since I'm starting with moles here, that's got to come down here, moles of calcium. And the conversion says for every 1 mole of calcium, now I get lazy, I don't like to write 6.022 times 10 to the 23rd, I just write A for Avogadro's number. But until you have this number solidly memorized, I strongly suggest you write it out. Until then, once you get it solidly memorized, you can go ahead and shortcut it to Avogadro's number. Atoms of calcium. Moles of calcium cancel, so now you can get out your handy-dandy calculator and come up with an answer. Okay, when I picked up my calculator, I ended up with 2.7099 times 10 to the 25th. Let's check out sig figs. Ooh, 2 sig figs. So 2.7 times 10 to the 25th atoms of calcium. Cool. We're done with that one. This problem is going to ask you now to combine both of those previous examples. So let's take a look at what we have. We in this problem are starting with grams, and we have to get to atoms. Well, the only way you can get from grams to atoms is you actually have to go through the mole. To convert from grams to moles, what are we going to use? Molar mass. Where do you find molar mass? Periodic table. To go from moles to atoms, we're going to use Avogadro's number. Where do you find that? You memorize it. You need to know that. So here we go. Calculate the number of atoms. We're going to start with what's given. 23.6 grams of zinc. Don't get lazy. Write it down. I know it seems silly. Believe me when I say it will matter. Okay, since grams is there, it's got to come down here. So we have grams of zinc. And according to our plan, we're going to go from grams to moles. Moles of zinc. Well, for every 1 mole of zinc, if you look at the periodic table, it says 63.55. I hope. I'm going to check. Hold on. Zinc. Okay, I got that wrong. So 65.38. I gave you copper. 65.38 grams of zinc. Okay, good. Well, that gets rid of the grams of zinc. According to our plan now, we have to go from moles to atoms, and we do that by using Avogadro's number, which is 6.022 times 10 to the 23rd, which I'm too lazy to write, so I'm just going to write Avogadro's number. Let's see, moles is here, so 1 mole of zinc contains Avogadro's number of atoms. Now you're ready to do the math. Doing that, I should take a look at sig figs. Here I have 3 sig figs, so my final answer will be 2.17 times 10 to the 23rd atoms of zinc. Yay, we're done with this one. There's more. Calculate the number of atoms in this many milligrams. Okay, so we're going from milligrams to atoms. Don't call me names. I know you're thinking it. Don't do it. It's good for you. Okay, we got to go from milligrams, and from here we're trying to get to atoms. Which plan? Well, plans are helpful. They really do make your life easier to solve the problem. So can you go from milligrams then to grams? Good. How about from grams then to moles? And then from moles to atoms. Yeah, that should do it. All right, we're given this many milligrams, so let's see. I'm going to change my pen color. 128.3 milligrams. And there's 10 to the 3rd milligrams for every 1 gram. And 1 gram is here, so that's got to come down here. And I know that for every, how are we going to go from grams to moles? Yes, that would be the periodic table. So let's see. The periodic table says for every 107.87 grams of silver, we have 1 mole of silver. All right, so grams of silver have canceled, milligrams have canceled. We are now left to convert from moles to atoms. So for every mole, we got moles have to come down here. So moles of silver, and we're trying to get to atoms, and you use what? I'm going to pick on a student who walked in. Alex, how do we get from moles to atoms? And he's just going to look at me. Allie, how do we get from moles to atoms? Avogadro's number. 6.022 times 10 to the 23rd atoms. So pick up your handy dandy calculator and see what you get. Okay, so let's hope I'm right, because when I put it in my calculator, I end up with, oh, gotta check sig figs. 4 sig figs. So 7.163 times 10 to the 20th atoms of silver. Please, if you don't get that number, you probably have calculator error, and if you can't figure out your error in calculations, please come see me. The biggest mistake students make is how they enter it. Make sure you're using the E function here, the entire numerator put in together, and then hit enter. Then hit in your calculator divided by, you need to put all of this in parentheses, then hit enter. If you're still not getting this answer, please come see me.